I think we can start now. So good morning, everyone. My name is Roberto Parrondo. I'm the Business Services Coordinator at CEEI Asturias, which is the lead partner of this CET virtual project. So on behalf of the project, we want to thank you all for your attendance and interest to participate in this INFODAY event that has a very clear objective, which is to help potential participants, basically startups from the Atlantic area, better understand the technological challenges and their context so that they can fine-tune solutions according to the challenges proposed. Hope you enjoy it and find it interesting. And for your information, this session is going to be recorded and put it at your disposal through our website. Okay. Before starting my explanation about how to submit proposals in this call, so I would like to introduce you briefly what we try to do in this project, what is the 80 virtual missions. Basically, we want to propose an open innovation methodology to respond efficiently and effectively to security and safety in maritime conditions within the Atlantic space. So in the following slides, we are going to show you how we do it. And it's important also to point out that this project is funded by the Interreg 5B Atlantic Space, which is a European transnational program that promotes collaboration among the 36 regions that belong to the Atlantic space in 5 European countries. So the regions represented in this 80 virtual project are Pays de la Loire in France, Southern and Eastern in Ireland, CENTRO and Lisboa in Portugal, and Basque Country and Asturias in Spain. So this project was initiated 3 years ago, more or less, and it's expected to end in December 2022. So back to our missions. So we intend to increase safety and security maritime condition operations by means of accelerating the digitalization process of the Maritime Safety Training Center. So, but I guess that you are now wondering what Maritime Safety Training Center is. So they are basically public institutions whose mission is very clear. They need to train elite staff teams that are going to perform, that are going to carry out very high risk operations in maritime conditions. We are talking about firefighting procedures, rescue operations. So this digitalization process will allow the centers to incorporate cutting-edge technologies regarding Internet of Things, big data analytics, and vision technologies in simulation-based training systems in collaboration with the startups of the Atlantic space who are going to act as digital enablers. So the whole process is going to be supported by a research organization and also experts in the field of Industry 4.0. To make it possible, we count on the participation of the following entities in our consortium. Of course, maritime safety training centers. They are going to be the key actors of this project since they are going to participate in every stage, okay? We have with us the Centro JOVELLANOS, belonging to the Sociedad Salvamento y Seguridad Marítima in Asturias, the MUNSTER Technological University in Cork, Ireland, and the ESCOLA Superior NÁUTICA Infante Don Henrique from Lisboa, Portugal. Business innovation centers, they are also very important since they are going to act as national contact points and stimulating and encouraging their community of startups to participate in the different calls. In this case, we count on the participation of CEEI Asturias. We have a little problem with, okay. In this case, CEEI Asturias, IPN in Centro Portugal, Laval Magic Technopole in Laval, and Cork Big in Cork, Ireland, And last but not least, Tecnalia Foundation, who develops and adapts the methodology, the different working methodologies of the project, and support, in this case, the maritime safety training centers throughout the different stages in their digitalization process. Okay, so let me also introduce where the most important phases of the project are. So the first one is the diagnosis, which is focused on the determination of the current state of digitalization of the centers. One of the most important deliverables of the project is the diagnosis tool, a tool that allows us to better understand what are the needs, what are the processes, in which the introduction of these digital technologies could really make the difference in the centers. So Tecnalia, in this case, based on the results that we obtained through this analysis, combined with interviews and meetings with the centers, they all were capable of defining the challenges that are going to be promoted or included in the different calls. The next one is the selection, which is the key phase that is possible, is the stage for establishing the pairings between the maritime safety training centers and the STORAPs, that altogether they are going to implement the different solutions. So this whole process is also carried out through a dedicated platform that we developed within the project. And it allows us to carry out the different stages of this selection event. Okay, this selection event is going to be, the selection process is going to be ended through a selection event in which, in this case, the STORAPs selected, in this case, or pre-selected, in this case, by the centers, are going to compete to be the winner of these challenges. Okay? And also, the last one is the implementation, and it's regarding the prototype and implementation of the solutions, in this case, by the parent already established. Okay, so in order to help them carry out or implement the solutions, they will have access to different methodologies, webinars, information, and also experts, which is all these combined will help them to speed up the process of the definition and also implementation of the solutions. Okay, so let's go back with the submission process. So all this information about the challenges, the calls, and so on are accessible through our website. Okay, you can write down the URL of our website, which is the one that you can see on the screen. And as I said, you'll have access to our website. All this information is included in the call section that you can see now pointed out in the screen. And clicking on that, okay, you can have access to the information regarding the third call, okay, which is called as vision technologies, but also we have included other challenges in Internet of Things. To get to this information, you have to click on this button, in the plus button, and you can see now which challenges are included in this call. 3 challenges are focused in vision technologies, and 2 challenges are focused in Internet of Things. Okay, so if you are interested in one of them, put an example, set an example, for example, the vision technologies proposed by ENIDH, clicking on more info, you can see all the information about the contents and definition of the problem, the challenge description, the requirements, the expected outcome and results, the budget, okay? And all this information is also, or you can download it as PDF, okay? Have that option, okay, in this definition of the challenge. So who can participate in the process, okay? Basically companies that have to fulfill 3 specific requirements. One of them is regarding the size. The companies or the applicants in this case must be considered as SMEs, okay, according to the European definition. Self-employed associations or partnerships are not eligible to participate. The origin, also the companies must be from one of the region eligible of the or belonging to the Atlantic area, according to the cooperation area of this program. In the case, for example, of Spain, companies from Galicia, Principado de Asturias, Cantabria, Basque Country, Huelva, Cádiz, Sevilla, or Canary Island could participate in the projects, proposing solutions to one of these challenges. And also, the companies must fulfill the 3rd requirement, which is regarding or related to the date of incorporation. They must prove that the date of the incorporation of the company has been set after January 1st, 2010. Okay. So, how to submit a proposal? Also, you have to go to our website, clicking on the call section, and before going to the challenges, I really recommend in this case to go or to download the terms of the reference. It's very important that you read it carefully, this document, because this guide, okay, will give you, okay, key information so that you can prepare properly the solutions, okay, also the requirements that you have to fulfill, and also information about the stages, okay, through the selection process is going to be carried out. So the first thing that you have to do is to download the terms of reference, read it, and then you can proceed with the preparation of the solution, okay? So, as I said, if you want to propose a solution in this 3rd call, okay, you have to click on the plus button, and let's set an example that you are interested in the Centro Jovellanos challenges. In more info, at the bottom of this page, you'll find this apply section. Okay, if you click on the applications, you'll have access to this application form, of course, that you have to fill with the information that you can see on the screen now. And also you have to allow, let's see, the memory about the solution that you are going to propose to these challenges. Memory that you can find just below the terms of reference, okay? This is a template in Word that you have to prepare, and also you have to follow some rules that are indicated in the terms of reference, which are, so the basic information that you have to include is about the general information of the company, the description of the solution, the innovative approach, okay, according to the current stage of the technology, the planned activities that you are going to carry out for the implementation of the solutions, the background, the technological background of the company, in this case, previous successful previous experiences about these technologies, the company resources that you are going to provide for the implementation stage, the budget, and other relevant information that you consider necessary or interesting in this for this proposal. Okay. After that, you'll have to also to upload the legal documentation for eligibility. Mean the evidences, the documents that proves that you can are eligible or is you are eligible to participate in the process. This legal documentation is related to the following documents: the legal entity form that also you can download through the terms of reference, the legal existence, the company register, and also, of course, the company must show the evidence of the date of incorporation. And the SME condition, okay? We have, or we provide a specific link in which, okay, you can, at the end of the process, you receive the result if you are not as SME according to the European definition. And also you have to include the balance sheet and the profit and loss account of the last year available, okay, also as evidence. When you have finished uploading all this documentation, you can agree on the terms of privacy policy of the project. And it's very important that you submit your solution before April 13th, okay, at 5 p.m. Central European summertime. Okay, so this is the limit, this is the deadline, so that you can submit your solutions to the challenges that you consider interesting for you. Okay, so I also want to give you, okay, information about the eligibility rules that are important to bear in mind for the preparation of the solutions. Of course, the participants must fulfill and respect all the eligibility conditions. All the information must be readable, accessible, and printable. The memory is very important, must be completed in English, okay, in Arial 10, and not exceed 10 pages. The memory must include the budget for the services. For the definition and implementation of the project grouped by phases, and this budget must be less than 15,000 euros, okay, VAT excluded. And also, of course, in this description, estimated costs, hardware, sensor, glasses necessary for the implementation of the solutions, bear in mind the value for money. So this is an estimation, just be considered in terms of assessment of the state of art of the technology. So the equipment in any case will be provided, will be made available by the maritime safety training centers. And also it's very important that an applicant can submit just one proposal to each challenge in every call, okay? So the selection process, you can see more or less what is the scheme of this selection process. So the first stage after the submission process is closed, we need to validate, we check, I mean, the eligibility of the proposals that we received. So these proposals will be validated, provided that all the documentation has been sent, and the memory is completed and understandable, and of course all the proposals fulfills all the eligibility criteria. Okay, so this the deadline for the validation is 15 days after the cutoff of the call. So if after this is late, non-eligible proposals will be rejected. Okay, then the ones that have been validated, in this case, the centers in collaboration with Tecnalia will carry out the assessment of these proposals according to the criteria that you can see now on the screen about the currency of the proposal, experience and background, evaluation of the technology and innovation, the risk evaluation, availability and assessment of the company resources, the budget, of course, the feasibility of the budget is also very, very important, and let's see the time frame of the implementation of the solution, and other added value that is granted by the startup in this case. So as I said, the selection process is going to be ended through or by means of a selection event, startups competitions, in which, as I said, they're going to compete in a fast track pitch presentations, 3 minutes by each startup. And also they'll have, the preselected ones will have the opportunity to have a meeting with the Maritime Safety Training Center so that they can give further explanation about the information that is contained in the proposal. Okay, so the final score of the selection will take into consideration the assessment score, the pitch score as well, and also the interview. Okay, according to the formula that you are seeing now on the screen. Okay, so when the process is finished, okay, we'll initiate the next let's see, the prototyping and implementation process. And you can see now which is the time frame of this process. After the signature of the contract, basically for 1 month, the centers and the startups will work on the definition of the solution, and they'll have 5 months for the implementation, and also the deadlines or the moment for receiving the money from this, in this case from the center, are established, as you can see on the screen. Okay, so why to participate? Why is important, I think, for the startups to be involved in this process, in these calls? Basically, because the money that, in this case, they're going to receive, the startups, I mean, is based on a client-provider relationship. There's no grant for the startups, okay? They are going to invoice the centers and they'll receive the payment according to it, okay? So also, I think the startups is important to have another, let's say, successful case that we can add, okay, to the previous one. So they receive, or they are going to receive, notoriety in this case, the international visibility through the participation in 80 virtual projects, which is an international project, and also they have access to agile methodologies, webinars, and so on, so that they can, in collaboration with the centers, for the acceleration of the process. And also, of course, I think it's important to establish, or they could establish, long-term relationship with these centers. Okay, that probably could be considered as leverage for their consolidation and growth process. So that would be all by my side. Thank you very much for your attention, and of course, I can share with you my contact details. I'll be glad to respond your doubts or anything that you need to participate in the process. Okay, so thank you. I don't know if we have some. Okay, we have no questions up to now. So we are going to continue now with the presentation of the challenges. We are going to start with the first Maritime Safety Training Center, which is ESCOLA NÁUTICA INFANTE Don Enrique. ENIDH, in this case, are going to present those 2 challenges in this call. The first one is...
Excuse me, Robert, you have a question.
Okay. Thank you. Okay, actually. Components name. I think the startup in this case has to supply or provide, let's see, the services for the implementation of the solution. The hardware has not been provided by the startups. Okay. In this case, they have to recommend what kind of hardware. Okay. In this case, the center could buy, but in another way, out of the services, in this case, that the startup have to provide to the center. I don't know if I respond to your answer. Okay. We have no. Okay, understood that the startup only provides services, but as another contract, the startup can provide supplies. The startup only can recommend hardware supplies. In this, for the 15,000 euros, hardware is out of the equation. These 15,000 euros are only for the services, for the implementation of the solution. The hardware, as I said, is not going to be included.
Hello, Roberto.
Yeah.
Perhaps I could add a view. I think, I'm not sure whether this could be taken as definitive, but this is the way that I understand it. We have a budget, a 3,000 euro budget for capital costs, hardware, equipment rental, and so on.
Mm-hmm.
And as part of the process of when we would sign a contract with the startup, they become an approved supplier for our organization. So if they send us an invoice, I don't think it would matter what it's for. If they have hardware in stock, we would buy it off them out of that 3,000 euro budget. So they would invoice us as they would for services, but they would be invoicing us for equipment. Or maybe we could rent equipment from them. I think these are possibilities. But it comes out of the separate budget. As you said, the 15,000 is only for services. But I understand the comment, the question, because anybody involved in electronics is aware of the shortage of semiconductors. It's really having an impact on all of our work. So.
Mm-hmm. As I said, okay, the 15,000 euros are only for services. In this case, for the implementation of the solution. This is I think, the key point that I want to point out in this, for this delivering services. Okay. Okay. So we are going to continue with the presentation of the challenges. As I said, the first Maritime Safety Training Center is going to be ENIDH. And Joao Frade, in this case, which is the captain of the Merchant Marine and professor in the navigation area at ENIDH, is going to carry out the presentations focused on vision technologies. So, Joao, as you want, the floor is yours.
Thank you, Roberto. Good morning, all. My name is João Frade. I'm a lecturer in navigational area in the ENIDH, and I'm a member team coordinator of these projects. So I will present our channel for vision technologies, and at the end, as Roberto said, I will be available for also any questions you have. So ENIDH, it's a public polytechnic higher education institution, and as higher education institution is a center for creation, dissemination, and transmission of culture, science, and technology. ENIDH activity centers on the field of education, professional training, research, and service to the nautical and national and international communities. Our campus is located in Passo de Arcos, Lisbon, in front of Tagus River, and it was founded in 1924, and since 72 has been located in Passo de Arcos, as I said, and it is the only public higher education institution dedicated to training in the maritime port area in Portugal. Our campus have many facilities for maritime training, as you can see in the map and in some pictures. We have student residents inside our campus. We have simulations, labs, gyms, firefighting training park, workshops, and so on. This is our main facilities. So we have two departments, Department of Transportation and Logistics and Department of Maritime Engineering. We have 5 undergraduate courses and 2 graduated courses. So 3 in the Department of Transport and Logistics, Deck and Bridge Operation, Port Management, Logistic and Transportation Management. And in Marine Engineering, we have Marine Engineering and Marine Electro-Technical Engineering. In graduated course, we have Deck and Bridge Operations and Marine Engineers. So we also provide all requirement maritime certification course for seafarers. As you can see, the STCW short course are available in our institutions according to the STCW convention. So vision technologies, our proposal will be development and solution of vision technology, immersive 3D environment that can show the celestial bodies above the horizon with the essential detailed information to train celestial navigation. Our solution will allow students and all navigators, of course, to understand better the main topics of astro navigation. And astro navigation is part of requirements of STCW convention. The standards of training, certification, and watchkeeping convention requires that training and assessment of seafarers are administered, supervised, and monitored in accordance with the provisions of the STCW code. And you have the knowledge of celestial navigation is part of STCW code, including the ability to use celestial bodies to determine the ship position. And our solution will allow the students and the deck officers to understand better this point. So the application will be better familiarized to the main topics. The astro navigation is the only alternative method to electronic means to determine the ship position in the ocean navigation. In this sense, it becomes essential to familiarize the students and simplify the teaching and learning process of these methods. This is our main topics. Will be easy to understand these matters because, of course, the application will be allowed to see in 3D environment, so it will be easy to understand some topics. So the description of need, one of the problems identified in teaching astro navigation is understand the main topics are the coordinate systems, the triangle position, and the apparent movement of the celestial bodies, as you can see in its small diagrams. With the immersive 3D environment, will allow the students to see the celestial bodies above the horizon with essential detailed information for astro navigation. The challenge definition. So we propose the development of a solution of vision technology, and immersive 3D environment that can show the celestial bodies above the horizon with essential detailed information to train the celestial navigation. This solution will allow the observer observe the 57 stars and their constellations, the 4 planets, the sun, the moon, and show the Aries on the celestial sphere with the observer located on the deck of the ship. So the 57 stars, it's the stars we use for astro navigation. So you only need these stars, this 57, the 4 planets, the sun and the moon and the Aries. We don't need all the stars. The application will allow, depending on the geographic position and time required, identify the celestial bodies above the horizon. This is an example where you can see the azimuth and the altitude of the star, the celestial horizon. This is just an example. And when we select the star, the observer should graphically visualize the horizontal and equatorial coordinates. So this is the point. The requirements. The type of solution to be proposed must be within the scope of vision technology and must fulfill the following technical requirements, with the main building a virtual sky celestial navigation, and will include the possibility of introducing the geographic coordinates of any localization for the visualization and time required, automatic update of the coordinate of nautical almanac for each year, possibility to select each type of celestial coordinates in order to view only partial information, as described on the expected outcomes. We will see next. The expected outcomes, we want the solution proposed to be developed as the following some of the expected outcomes we want. Attractive and interactive application with the different colors displayed to better show the info. As an example, it's only an example, but this graphical can show with the colors, and we can identify all the main topics for astronavigation, so it will be better for the students and for the deck officers to understand where are the coordinators or the triangle position or the apparent movement. Identify all coordinating systems, show the astronavigation triangle, show the prime meridian, show the apparent motion of the sun, moon, and stars in real time or faster mode. The faster mode is to allow the students and the deck officers to better understand the 24 hours apparent movement. For example, in the fast mode, in 1 minute, we can see the 24 hours apparent motion of the celestial bodies. The ecliptic with the position of the 4 reference points. Also show the zodiac and the solar and lunar eclipse in the position they happen. So this is the main expected outcomes. Of course, we will be available for the startups who have interest in the submit a proposal to explain and to help and give all the support in astronavigation. So we have that knowledge. So and we will share with you to prepare our solutions. The budget, as Roberto said, is 15,000 euros for the budget. We will have also more plus 3,000 for the hardware procurement. And for sure, the proponent will choose the most suitable software and the hardware for the success of the change. So the startup can decide the most suitable software for develop this solution. So for my side, it's all. I'm available to clarify any situations you want or any questions you have to try to understand better this challenge. So from my side, it's all.
Okay, thank you very much, Joao, for your interesting presentation. We have no questions right now in the chat, so we are going to continue with the next presentation from ENIDH as well, in this case by Pedro Silveira, who is assistant professor at ENIDH. So Pedro, when you want, you can start with your presentations of the Internet of Things challenge. Okay.
Good morning. Can you see my presentation?
Yeah, we can see.
Yeah. Okay. So good morning, everyone. My name is Pedro Silveira, as Roberto mentioned. I'm a professor, assistant professor at ENIDH. As João has already described, we are a higher education institution, which is mainly focused on the education and training of merchant marine officers. We also have some other courses, as João mentioned, in the area of logistics and management, but our main purpose of existing is the education and training of merchant marine officers. So for these courses, All aspects of maritime safety are covered in the curricular study programs, which range from evacuation, survival at sea, search and rescue, firefighting, occupational safety, among others. Some of this maritime safety training is carried out on small crafts. And by small crafts, we mean lifeboats and rescue boats and other small crafts. These vessels are used to develop the students' handling and rescue skills in realistic scenarios, because we are doing it in the real world, where the crafts are being affected by winds and are being affected by currents. And all of this means there's an extra difficulty when the students are trying to achieve the objectives of the different exercises that we propose. So during these exercises that we conduct in our lifeboats and rescue boats, we are constantly assessing the students' performances. And also we are suggesting corrections to their performance to improve the outcomes. Of course, sometimes it's not as easy as it sounds to explain to a student that has no experience in small craft handling, to explain to them why the exercise went wrong, or how could they done it better. So obtaining data from the vessels and from the rescue dummy that we use during the rescue exercises, and also from the weather, like the wind direction and speed, could be extremely valuable to increase the students' understanding, or the way that we can communicate better to the students how they can improve their proficiency, and what are the effects of winds and currents and everything else on their performance. So we propose the development of a solution to allow for real-time monitoring, of small craft training, and to improve the exercise debriefings using Internet of Things technology. So the objective of this solution is to monitor in real time and record for future use all the movements of the training vessels and of the rescue dummy that we use for rescue training. And the data can be used, as I said, to better to improve the corrections that we give to the students, but also to be used at a later stage in a debriefing, and also to be used in research. The solution should also be able to record and replay data from an existing weather station that we already have in our school. So what data do we want to collect, store, and use for real-time visualization and for debriefing? So the idea is to have 3 GPS sensors, which would be 1 in each vessel and 1 in the rescue dummy. Also to have 2 inertial measurement units, or equivalent, to be defined with the startup, with accelerometers, gyros, and magnetometers. Also, we want to collect data, as I said, from the weather station. And the data from the weather station basically is to have wind direction and speed. We want to have a local data storage on campus. We want to have an application to debrief the students in the classroom, and also a mobile app to enhance training in real time, and to be able to show the students exactly how they are performing. So both the classroom application and the mobile app shall be able to graphically display the positions of the vessels and of the dummy in a dedicated chart-like environment and on Google Earth. These applications shall also be able to provide a user configurable dashboard with numerical information collected by the sensors. And this dashboard should have the possibility to add other IoT sensors in the future. But what we are interested in right now is in getting in the dashboard the vessel's course of ground and speed of ground, the vessel's heading. This course of ground and speed of ground is obtained from the GPS. Vessel's heading, roll angle, pitch angle, and rate of turn. The vessel's position, also coming from the GPS, will be graphically displayed on the chart. And this heading, roll angle, pitch angle, and rate of turn are obtained from the inertial measurement units. We are also interested in obtaining the bearing and distance to the dummy and to other vessels, and also the dummy course and speed, which is useful to estimate current. The wind direction and speed, as I said, is obtained from the weather station. Both the classroom application and the mobile app shall be able to start and stop recording and replaying of data. The solution is required to enable the configuration of an UDP port to receive AIS data, live AIS data in standard format. The objective of this is to, if we are operating in an area where there are ships with AIS enabled, that their positions are also shown on the graphical interface. A copy of all received data in its raw format shall be saved to be later used in research. What are the expected outcomes of this solution? So we expect to get a user-friendly, highly flexible and configurable solution to enhance the learning of small craft handling and search and rescue techniques. We expect to collect and store data for future research projects. We expect that this solution will have a positive impact on the proficiency level of students once the training is completed, due to the possibility of performing more accurate analysis and corrections of their performance, both in real time and in the classroom. And also, we expect that solution that provides tools to the trainers to improve the way they transmit knowledge and potentially increase the students' interest in maritime safety, related subjects, and also in the Internet of Things technology. So this is an overview of the system. We have our state-of-the-art lifeboat and rescue boat here with their sensors transmitting data. Also, the dummy has its own sensor, GPS sensor transmitting data, and our classroom application where the data will be received, and also the weather station will be located in our school. The budget, as mentioned before, will be maximum €15,000 for the solution for the services, and a 3,000 euro budget for hardware. That concludes my presentation. Thank you very much for listening, and I'm available to answer your questions.
Thank you very much, Pedro. I think we have two questions related to this challenge, in this case, proposed by Francisco Alay, by Pibico. He asks, which are the components and output signals of the actual weather station?
This weather station, I'm not really into exactly how it works. I know it's connected to WindGuru, so we can look into that and try to obtain that information. But at the moment, I'm not sure of what are the output signals. But it's already transmitting to WindGuru, so I guess it would not be too hard to tap into that data.
Mm-hmm. And also the other question is, instead of a mobile app, can be done with a web app from a mobile?
Yes, if the startup finds that this is a better solution, I think we have nothing against it. Yeah.
Okay, thank you very much, Pedro and Francisco, for your questions. So we are going to move on in our session. Okay, this is the turn now of the Munster Technological University. This Maritime Safety Training Center also is going to propose two challenges in this call. So both of them are going to be introduced by Mike Liu, which is a researcher in the field of mechatronics at the Munster Technological University. So Mike, when you are ready, you can start with your presentations. I don't know if Mike is having some technical problem. Mike? We are going to wait just 2 minutes, okay, for this, for the appearance of Mike. He can start with the presentations. We repeat previously, of course, all the questions. You can send them through the chat tool, so that in this case the centers could give an answer for them. Probably he's having some technical problem with the Wi-Fi system at the Munster Technological University. We're going to wait a little bit for him. This kind life situations and problems that, of course, we need to suffer in the celebration of these online events. Sorry for that. we hope to solve this technical situation as soon as possible. Okay, sorry for this interruption. I don't know how long it's going to last. Just a question of minutes, sorry. The session is going to be resumed as soon as possible. Sorry again for these little problems. I think Mike is now with us again. Michael, are you there? Michael?
Roberto, I'm so sorry.
It's okay. It's okay.
What's happening?
I don't know. I don't know. But you disappeared.
No, wait.
Okay, we can now resume the session. Okay, you can start now with.
Can you just one minute? I just want to check what happened.
Okay, please, as soon as possible.
Yeah, I'm sorry. I can only apologize. We had the network, the Wi-Fi network I'm using disconnected me. So the IT people have been very good here and have managed to reset everything. I hope it'll stay connected for the next hour or so.
Okay, I hope it is too. Okay, so I think you can start with the presentation of your virtual technologies challenge. Okay, when you want and when you are ready.
Let me just share my screen then.
Okay, we can see it now. Okay,
Very
so
good.
Mike, the floor is yours.
Thank you, Roberto. Let me start by introducing myself. My name is Mike Grew, and I'm a mechatronics researcher at the Halpin Research Centre, which is part of the National Maritime College of Ireland. And we are a research group within the Munster Technological University. Our mission is to research themes in the maritime field, which include learning development, maritime safety, security and defence, blue growth, and maritime mechatronic design and innovation. So before I talk about our challenge, I'm just going to briefly outline the structure of the Munster Technological University, because you may wonder why MTU is involved with nautical training. The name comes from the province of Munster, which is the southwest side of Ireland, and the two counties are Cork and Kerry, and these are where our campuses are. So we have a campus in Kerry, and what's significant about the structure of MTU is that within the organization we have support for research centers with special expertise, and at Kerry we have the ACE team, which are heavily involved with virtual reality, and in the main campus in Cork we have the Nimbus Technology Gateway, and they specialize in IoT and embedded wireless computing, and also they have an extended reality lab. So with these resources at our disposal, we have a good deal of flexibility in the way that we can manage our project. And finally, the Maritime College itself, which is in a town called Ringaskiddy on Cork Harbour. As you can see, the Maritime College has three main activities. The research centre, we have a nautical school, which deals with cadets for all kinds of nautical studies, deck officers and engineers, and also is tied in with the Irish Navy, who train all their seagoing cadets, the basic seamanship training. And finally, the Maritime Safety Training Centre, which teaches, as you saw in Yao's presentation, all the normal types of offshore safety training, including firefighting. In this project, we'll be acting as a go-between between our colleagues in the Maritime Safety Training Centre, their instructors and managers, and our role will be to, as we have done already, establish the needs of their needs, set up and manage the contract with the startups, and coordinate the projects once they're running with management and instructors. So onto our challenge. Imagine that you're a trainee and it's your first exposure to firefighting training, and you're presented with flames and inferno like this for the first time. or you might be inside the fire training unit, where we practice firefighting, wearing breathing apparatus, again, for the first time outside of the classroom. This can be very intimidating. It can hold back learning because it takes time for novices to acclimatize to the conditions and to put what they learned in the classroom into practice. Their perceptions are dull during this time, tunnel vision, for example, so they miss doing essential checks, and the beginnings of bad habits can become formed, which is an undesirable training or learning outcomes. Moreover, time is wasted by the instructors who have to help these candidates, because everybody who works offshore, whether it's on a ship or on an offshore installation or on a gas installation, must have these qualifications in order to achieve to be allowed to work. So the instructors try and get everybody through the courses. So these are, and I should also mention that once they've done the training for the first time, the training has to be repeated at intervals, can be as long as 5 years. So there is an issue with retaining this knowledge, even though drills are carried out regularly on board ships and installations. And of course, we will get candidates coming back to the college for their recurrent training. Some of them will be raw recruits, some of them will have been already have done the training 3 or 4 times or been working for decades. So there's a broad spectrum of trainees to cater for. And so those are the challenges that face trainees. Challenges face instructors as well. For example, in this case, we see the conditions inside the fire training unit. Smoke and reduced visibility makes it difficult for the instructors to really accurately monitor what the trainees are doing, whether they're carrying out procedures 100% properly or they're missing checks. It's a noise environment as well. So, for example, when the instructors are demonstrating, it's difficult for them in the real time, in the real space, to give coherent instructions. And finally, they have a problem with people who come to the training centers for courses other than the basic firefighting or advanced firefighting, for example, leadership skills training and leadership evaluation, because they have to spend a lot of time getting the candidates up to speed with our equipment, which may be different from the equipment they're used to using. And this is a problem because they're being assessed for being evaluated for leadership skills, not for their ability to use our equipment. So much of the time, the instructors are helping them with the equipment and showing them, familiarizing them, when that time could be spent actually doing the leadership evaluation exercises. And finally, managers face a challenge. They come to work every day and they see sites like this, where there's smoke, emissions, carbon dioxide emissions from the live flames or live fuel that's being burnt. These are not sites that are welcome in this day and age when we're trying to reduce the environmental impact of training, and of course the cost of it as well. So we'd be looking for ways to reduce the carbon footprint of training. So these are a summary of our challenges, and the usefulness of virtual reality, immersive reality technologies are well proven. For example, this slide shows a well-known firefighting training system. And the question you might have in your mind is, why hasn't technology like this been already found its use in marine firefighting training? And the answer is, as Jan mentioned earlier, he mentioned the IMO and the Standards of Training Certification Watchkeeping Seafarers Code. Our training is all accredited by organizations such as the IMO and OPITO for offshore installations. They not only mandate the syllabus, the content of the courses, but they also define the manner in which it is delivered. And for firefighting, the resolution or the legislation from the IMO that applies to that, I'll quote from that. It says that the training must be practical training, should take place in spaces which provide truly realistic training conditions, e.g. simulated shipboard conditions, and whenever possible, training should be carried out in darkness. So they're asking for as close to real life as possible, and really the only way you can do that in firefighting, considering the heat, the flame, and the type of equipment it's using is in live fire training units like ours. However, that won't be the case in the future. Virtual reality is proven, so we want to embrace it if we can, but we're not in a position to do that yet with this challenge. What we do want to do is we want to add value to our current training syllabus. And by that we want to include auxiliary training. So this is training that candidates can do in their own time, maybe prepare them for the training with us so they can do this at home before they come to the centre, or when they're actually doing the training, they could do this in their hotel room or in the library here if we had a suite of VR equipment that they could use. So it would be an ancillary add-on training. We could also make it valuable by making it available online, so they could be used for recurrent training. So people who are working offshore between their training sessions at the college could still maintain their currency using our VR exercises. And the secondary goal of this challenge is to provide a training simulation that is sufficient quality that observers from the IMO or from OPITO who watch what we're doing will begin to see that this is as close to real life as it needs to be brought into the training syllabus, which is the ultimate goal for this and the way we would gain the most. The way we want to do this is through 3 exercises. One is a simple walkthrough of the fire training unit, which I'll show you in a moment. The second is exercises in what's known as first aid firefighting. So first aid firefighting is what you do before you actually attempt to extinguish the fire. And we want to use gameplay that is based on portable fire extinguishers, fire hoses, and breathing apparatus. So the checks that you would do with this equipment before you would attempt to fight the fire. And finally, I'll talk a little bit more about this. We want to do a casualty search exercise, which will be there are complications with this because it will involve more than one person, more than first person gameplay. So a quick look at the FTU from the outside. These are just 20-foot containers that have been stacked together. It can be filled with smoke. Sorry, I'll just give you a floor plan. You can see there are a number of spaces with doors, steps, ladders, and the spaces within them have props that can be used with live flame. So, for example, in this set of shots, you can see on the left is the mock-up of the galley. So it's a cooker. The one in the middle is the accommodation area with a mock-up of bunks, and on the right you can see the flames as they appear. The flames are actually a gas produced by burning gas, and that is under the control of the instructors. When the trainees fight the fire, they cannot actually put it out. It only goes out with the instructors switch the gas supply off. So in that respect, this is not a perfect simulation. And on the right is a simulation of the engine room. and that has a deluge system. So the containers themselves are approximately 6 meters long by 3 meters wide and 3 meters high. For the walkthrough exercise, we do want to be able to navigate through all of the spaces, but we don't really require any gameplay. It's simply to acclimatize the candidates with the spaces in varying visibilities, so they get used to where the doors are, where the hatches are, the mechanisms for opening and closing them, and so on. For the fire extinguisher drills, what we're interested in are the essential checks that you have to do before you try and use a fire extinguisher. So the first thing you must do is raise the alarm, then assess the fire, decide what kind of fire extinguisher is appropriate, remove the anti-tamper-proof tag, which you can see on the example of a fire extinguisher on the right. Check the pressure on the gauge, check the hose condition, remove the pin, and then finally give the extinguisher a short burst to check that it has actually media inside. So at this level of training, we're just ingraining basic habits. This kind of training doesn't impinge on the training that they do in the classroom, and it's important that we don't, because, as I said, our training is accredited and we can't interfere with that. However, these kind of exercises lend themselves to being repeated. They're the kind of exercises that you want candidates to have already good habits ingrained, and they're more or less common sense. So, as I said, we're not impinging on the syllabus. We also would like to familiarize trainees with the checks that are done on breathing apparatus before it's used. So in terms of modeling these assets, modeling this equipment, I've already located 3D assets that are available online. So the workload in would mostly be in the gameplay, in interaction with these assets. They're already rigged, so they can be used in the game, but the game logic would have to be applied. That would be the main effort. We would also like perhaps to, for this gameplay, this is separate from the walkthrough, but for this gameplay, when we're assessing fire, to use the approximate layout of the FTU, but with realistic textures applied to the bulkheads and the ceiling to make it more like a cabin or more like a galley. So we would be adding the extra items that you would expect to find in real life. For example, fire points for raising the alarm, a telephone or an intercom panel on the bulkheads, again for telling somebody that there is a fire. Then other props like fire blankets in the galley. You would have a gameplay would be to choose which is the most appropriate fire extinguisher, go through the checks, and then finally approach the fire and trigger the extinguisher. It wouldn't be, gameplay would not continue from that point. It would either tell you with a tick or some way of feeding back that you have successfully completed the exercise, or maybe a burst of flame or something to indicate that you got it wrong, and then you could try again. So that's a summary of the first aid firefighting solution, and really that and the FTU walkthrough are the two main areas that we're expecting. The third is one which we're hoping for. If this is possible, it would be a great benefit, because the third area that we were told they have a need, the instructors here have a need, is with basic searching and escape or evacuation from smoke-filled rooms. So here is a team of 3 men who are carrying out what's known as the breathing apparatus, or BA shuffle. It's a way of navigating through a space, searching for a casualty, So they're sweeping the floor with their foot that doesn't have their weight on, their leading foot. The man on the right is his hand in contact with the bulkhead, and the other two are holding on to each other's waistbands, and their hands are also sweeping up and down. So they're checking for casualties, they're checking for the soundness of the floor, and of course they're doing all of this potentially in darkness. Meanwhile, they have to keep situational awareness. The man on the right is responsible for getting the team in and out of the space, so he has to always follow one direction, memorize which way they're going, and then they have to communicate clearly in a very noisy, potentially noisy conditions, and also where it's difficult to speak because of the breathing apparatus. They must keep an eye, very close eye, on the amount of air that they've got left. So in terms of modeling this, it's an issue because, of course, it's more than one person. It requires object tracking and person tracking. So again, I've identified technology that could be used. Whether it's within the budget of our project, I don't know. My thought is, if we have it depends on the experience of the startup. The startup already has experience with this technology or similar technology. We could move perhaps towards a demonstration. It wouldn't necessarily be the prototype that is the outcome that we would desire for the first two challenges. So as a summary of this is our body tracking. Real BA sets would be worn for the weight, but without actually the face masks. Some simulation of that, an industrial respirator would give the same kind of the same feeling for the trainee. And perhaps if we had time, we could build a stage to properly simulate, for example, an aperture or weakness in the floor that they would detect. So as a brief summary, we have two needs: to add value through the VR challenge or through the VR project, add value to our current syllabus. Our second goal is to make the legislation organizations more aware of the possibilities of VR and lower any barriers to it, because we see that as very much a technology for the future. We have two solutions in mind. One is a walkthrough of our fire training unit. The second is first aid firefighting. The third depends on the credentials and experience of the startup. And that's our casualty search or evacuation drills. Our budget is the same. I think you've seen this information before. What's worth noting, dealing with an Irish state body, which is what the Munster Technological University is, there are a couple of complications which don't affect the final outcome in terms of the amount of money that's available to the startup, but it does mean that you have to work with us in preparation. For example, we only pay 80% of what we're invoiced. 20% goes to the Irish revenue. The company, the startup that we're paying, then has to apply for that money from the Irish revenue, which is a standard procedure. They definitely get the money, but they have to be registered for Irish tax before that is possible. Also, VAT is involved. We pay the VAT, not the startup, but we do need details from the startup companies. And finally, the €3,000 that Jan mentioned in his first presentation for hardware, I think that would include other forms of purchase, so 3D assets, software licenses, hardware purchases, or maybe equipment rental, if that's a better way to proceed. And that concludes my presentation, Roberta. So back to you.
Okay, thank you very much, Mike. We have a question in the chat by Valerie Moreau. Hi, Valerie. Could you also accept, I think, augmented reality solutions, or do you only focus on virtual reality solutions?
I haven't considered augmented reality. I don't think that the training that they do lends itself to that in the sense I'm guessing you mean perhaps you would be using a fire extinguisher prop and it would be giving you clues or cues rather as what you should do, you know, pull the pin, check the hose. I think it would be an interesting experiment to try that. The issue with props, of course, is that they have to be synchronized with the game space. So the live prop, if it has a button to press, when you press the button, the state of that button in the game space must be the same as the physical button state, which can be done. I've seen modified hand controllers being used, rigged up to portray that kind of information. But again, it depends, I suppose, on the startup company's experience. I think it would be interesting for us to see that kind of interaction between physical assets and game assets. But no, that doesn't answer this question. AR instead of VR, I don't see why not. I think it would depend on the solution or that you're talking about.
Mm-hmm. Okay. Valerie, appreciate your answer. So I think we can move on to the next presentation, Mike. So if you want to start with the IoT challenge.
Okay. I don't know whether I can switch from one PowerPoint to another. No, I think what I'll do is I'll quickly stop sharing and then set up for another.
You have to stop sharing your screen and initiate the process again.
Yeah, here we go. All right, I will quickly change my notes.
Okay, we are seeing your presentation, Mike.
Okay, thanks. I hope we're okay for time. I'll be as quick as I can anyway. So
no, it is. Don't worry.
Okay, good. So there's no need to repeat the introduction, other than to point out that for this challenge, the Nimbus Technology Gateway that I mentioned before could play a part because they specialize in IoT, embedded computing, and wireless technology. So they would be available, their expertise is available for us to draw on if we needed. So this challenge is to do with survival craft training in Cork Harbour. So in the image on the screen, you can see in the center a jetty that leads out to a structure, and to the right of it is actually a pontoon. Further to the right, I'm moving my mouse pointer. I hope you can see there's a second jetty. It's a slipway with a pontoon at the end. This is not part of our facility. It's a public amenity, but as you can see, it's in very close proximity to our own facility. And beyond that is a bridge which leads over to a small island, and beyond the island, the bridge continues, and that's Hall Bowline, which is the Irish Navy base. So we're concerned, I'll just go through a couple more detail, these structures. So the first structure is for launching lifeboats. You can see on the right is, or in the center of the picture is a freefall lifeboat. And then there are other lifeboats which would be launched with mechanisms similar to those that you'd find on a ship that launches over the side. So the freefall cradle here, and then to the left is a davit with a boat ready to be launched. And the relevance of this is to appreciate that there must be deep water where you're launching a free-fall life raft. And that's not always the case, because the water in the Cork Harbour area is fast flowing, and the currents are often scour the sand quite rapidly. So there is a need to know quite precisely the water depths near hazards. Just go back to this picture. The training is done to a range of about 3 kilometers. So from the bridge in one direction, and then to a maximum distance from the jetty of just over 3 kilometers. So from the down from the lifeboat launching structure, there's a gangway to pontoon, which is where the survival craft and fast rescue craft, which is another type of craft that we do training on, are operated from. So these will be performing exercises in the harbour, and there'll also be, while that's happening, there's a safety officer who is standing by on the pontoon. Now, within the harbour are a number of constraints and hazards. Firstly, conditions are subject to quite rapid changes. The water depth varies, and when there's a wave heights and squalls pass through, we can have quite rapidly changing water conditions, which gives us a range of operating limits that are quite tightly specified. So above a Beaufort Sea State 3, which is a way of measuring both the wind speed, wind strength, and the wave condition, training is prohibited. Between state 2 and 3, at the instructor's discretion, training can continue, but he may be looking at trends in the weather and conditions and will curtail training, will stop the training if he considers the conditions are going to deteriorate. So for this reason, you can see that information he has about the weather that's present and the trends is quite important, because he might decide too soon in the training, or he might decide to stop the training when in fact conditions are going to get no worse. So the more information he has, the more detailed information he has, the better picture he has in his mind of what's happening, the more he's able to make good decisions and get the most efficient training. I've mentioned the wave heights. Well, here's a short an indication of how the wind, even on a mild day, we can get waves quite quickly building up as squalls go through. The water is shallow in places, surprisingly shallow, and the sand is subject to the effects of the current, which scours away areas unpredictably. I mentioned the public slipway, the other hazards in the area, the bridge beyond the island. All of these funnel the water and can create water channels that are hazardous, particularly to novice coxswains, the pilots of the boats. This kind of training is carried out for everybody who works offshore. They might be the only person available to pilot a survival craft. So everybody has to know how to do this, which means you get people who are very inexperienced operating these craft. And because of the scouring, here's evidence of the way that the sand at the bottom of the harbour is moved. Already this first span of the bridge has been blocked by debris and sand. So there is a need to monitor what's happening with the depth of the water and the speed of the water, because after a big storm, the first time you go out and train after a big storm, there may have been some quite large change in the environment. So this is our use case, a slide that just shows the main features for what we require, which is a sensor buoy. So we envisage a small array. This would be not the goal of the project now. The goal of the project now is just to produce one prototype, but the prototype must be simple enough and inexpensive enough to be duplicated. And in this vision, we have 4 in the water, 4 sensor buoys, and also 1 on the jetty itself. The reason for this is that the wind speed and wind direction is more usefully gauged from a visual indicator than from electronic measurement, because a windsock, which can be constructed so that when it's inflated fully, it's showing a wind at a precise speed. It's calibrated to that speed. So when the windsock is full of air, when it's rigid, the person you're looking at it can say, well, that wind is 15 knots or 10 knots. So they get an instant and very easy to interpret indication of wind speed. Electronic measurement, digital measurement is useful for trends and for a longer term information. But we think that probably a visual indication for wind speed and direction is also needed. So here's a survival craft in the harbour training and the safety officer on the jetty. So we have a requirement for water depth speed and water depth in certain specific locations where we believe that there could be a hazard due to the water depth, or the channel, the water speed would be increasing where a novice coxswain could have a problem dealing with it. So near the span of the bridge here, and water depth near the freefall lifeboat. The other buoys in the further out give instructors a view of maybe incoming weather. If there's a squall, he would see the indication on one buoy and would know that conditions in the other side of the harbour are still safe. And for dissemination, the safety officer is going to be requiring a mobile device, but we also have a requirement to monitor the data in an office. So we'd be looking to have probably the data sent to the cloud so that it can be viewed in more than one type of device. And that's important also because for long-term trends, we would require the data to be archived. For the platform itself, go into a little bit more detail now with the specific specifications and requirements. Now I'm coming to this as an engineer, so maybe I'm adding more detail perhaps, but this is how I would go about designing this, and these are the specifications that we are open, obviously, to discussion with a startup. For water depth, I've identified a suitable transducer. It produces a serial. I'm sorry for the audience who are not engineers, but our startups who are interested in this, I think they'll know what I'm talking about. So this produces a serial data. It's an NMEA standard message format. The downside of this kind of transducer is it does draw quite a lot of power. For water velocity, we have a sensor that that will be provided, and these sensors will be provided by Halpen, or MTU rather. It would come out of the €3,000 budget when we buy them, but these are not items that the startup has to pay for, or it doesn't come from their budget. The water velocity is a special sensor. We're in fact going to be beta testing it for another company, which is why I can't give you any more details. other than to say that the output will either be serial data or I²C. So it'd be a standard computer microcontroller communications protocols. Wind speed, electronic wind speed and wind direction, we can provide a reference design, which is a picture of a simple weather station that we built. What's unusual is the wind direction indicator has a compass built into it, because of course in a buoy or a floating platform that isn't a fixed reference point, you have to have a direction reference. And for the architecture, we propose a very simple hub and spoke system where a central MCU will be responsible for concentrating messages and assembling messages that a radio module will send. I'll talk about the communications in the next couple of slides. So the final run through of the full set of specifications. The primary sensors are water depth, water velocity. We also want digital wind speed and direction. We can provide a reference design. Communications, for the data hub, in the architecture we propose is a hub and spoke, and we would like the startup to use open source code libraries. So for example, Arduino. The data has to be archived, it has to be published to mobile devices and PC browser. We believe that the use case requires instantaneous wind velocity. So this has an impact, in fact, on the communications requirements, which I'll talk about very shortly. And finally, training is done in poor light conditions, so the sensor platform should have a light. In the first slide, I showed a number of devices. Only one is required for this project to be delivered by the startup. The buoys or the sensor platforms are only deployed for the duration of training, which is no more than 12 hours. It's usually less than that, and then they have to be recovered. So we would leave nothing in the harbor permanently. And the length of time, the duration that's involved, we would be monitoring for trends. We don't know yet. This would be something that we would talk to end users when the project starts. And the communications system that we use will have an impact on that too. And speaking of communications, the first thing I must say is that Wi-Fi is not an option. There is no way to connect into the building, the wiring inside the building, a device. We don't have that option. So it would either be 4G or IoT, and Sigfox would be a common way of achieving IoT connectivity. And this slide just shows that I've done due diligence to show that we do have 4G coverage in the harbour, and also Sigfox coverage is assured. So either of those two communication mediums would work. Now, if we're talking IoT, of course, we have to stay within the bandwidth limits, which are very constraining. So messages would have to be only 12 bytes long, payload, and we could only have a maximum of 1 every 10 minutes. So if we chose an IoT solution, this is why I mentioned earlier the wind speed visual indication, because of course, if you're only getting a data message every 10 minutes, that's maybe okay for trends that the data can be stored more frequently in the buoy itself and then averaged. But if you're only getting one trend data point every 10 minutes, that's not enough for an instantaneous wind. For the flotation device itself, the constraints are, or the specifications are, that it must be simple and low cost. The water depth is only at maximum 15 meters, so it doesn't need to have a long mooring. It should be compact because it will have to be deployed and recovered for each training session. So here's an example of a simple buoy that researchers have used. The disadvantage of a buoy like this for us would be launching and recovering. It's not a convenient platform. And this is an idea that I've had. Again, it's just an indication of how I approached the requirements, just using the simplest possible flotation device, which is a life ring, and on the with the sensor buoy above, or the sensor pod above, and the wind speed indicator, and below the water speed and water velocity and water depth transducers. What's interesting about this configuration is on the right you can see a sketch, and these two pods are actually my idea of a thruster, because it would be quite feasible with this simple set of requirements, particularly the short duration, 12-hour or less deployment duration, to consider an autonomous station keeping UAS. In fact, you would need no more than a computer, not a single board computer, a telemetry radio, and appropriate software, because the navigation for a station keeping for any surface vessel is very much simpler than the motion control algorithms for a flying autonomous vehicle. So we would keep our mind open to any suggestions or even a collaboration. So for this project, we could work with the startup. The startup would do the communications and the sensor platform, and then we would provide and the basic flotation system, so long as the flotation system is suitable to be both self-powered and moored, then we could make this a collaboration. Halpin would do the robotics and provide the propulsion. So this is a summary of our needs. So specialized water sensors, primarily water velocity and water depth. The frequency that we need this data is subject to a use case analysis. We might consider, as I put in the notes here, a hybrid design where we're getting the wind indication visually and the water information through, say, IoT. We're trending 10 minutes is, I think, a good figure to have in mind, and published to both mobile devices and PC browsers. The solution could be a tethered buoy or a station keeping UAS. Whichever case, it has to be simple and low cost, because we require maybe up to 4 of these, and the duration for deployment within a day of 8 to 12 hours. This slide is the same information we've seen before. The only change is that the hardware specification is different. So we'd be looking at radio kits, the sensors, fabrication costs, and software licenses, for example, a subscription to Sigfox if we went down the IoT route. And that's the end of my presentation, Roberta. So the floor is back to you, unless there are any questions.
Okay, thank you very much, Mike, for your presentation. We have no questions in the chat right now, so I think we can move on to our last presentation, which is in this case carried out by Jesus Loza. who is training services technicians at the aeronautics unit in Centro Jovellanos. So Jesus, okay, you are now connected. So the floor is yours.
Okay. Morning, everybody. I don't know if you are hearing.
Sí, yes.
Yeah. Oh, yeah.
But we are not seeing the presentation at the moment.
Okay.
We are trying to share it.
Oh. Okay, we're going to start. My name is Jesus, as Roberto introduced to me, and my colleague Ana, am I right? We're going to try to show to you key elements of our challenge for this vision technology challenge. I would like to start this presentation with a short overview of what SASEMAR is, our mission, and the Jovellanos Center. The Spanish Maritime Safety and Rescue Agency has the oil spill search and rescue responsibility in the adjudicated search and rescue area to Spain, about 3 times the Spanish surface. To reach this objective, we have a large structure, mainly 20 emergency response coordination centers, 73 vessels, and the Jovellanos as training center. Here, we offer training to different groups and professional sectors. For example, in the field of maritime traffic control, vessel traffic service courses, for the different professional groups of seafarers, the STCW course of the IMO, and training for all kinds for firefighters and emergency services, or regulated courses for offshore industries, such as oil, gas, and offshore wind industry. Okay. In the specific area of air operations, we work mainly with 3 groups: personnel transfer operation to offshore facilities, training for security and surveillance service crews, and a specific training for aircraft that carry out search and rescue operations. Obviously, this last group is of our greatest interest. As part of SASEMAR's resources, we have bases with helicopters, different types of helicopters, and fixed wings aircraft in different locations. There are 3 types, as you can see: AW139 helicopter, EC225 helicopter, and CN235 airplane. You have the main characteristics on the screen, and as can be seen, the main aircraft is the AW139, and we are going to focus in it. Our main goal is to offer a highly realistic experience to our trainees during the safety training program for passengers and crews of helicopters and airplanes. To have a more specific vision of some of our current capabilities in aeronautical training, I'm going to show to you a short video with some examples.
Jesus, we are not hearing anything.
Oh, excuse me. No. We are waiting for the video finish to
Okay,
the presentation.
Pero creo que
just for your record, okay? We have no sound
of the video.
in the video, yeah.
Ah,
Que no
que no tiene sonido del vídeo.
Oh,
We don't know what. Okay.
bueno, pues ahora ya lo dejamos. I don't know if you are hearing the video. At any way, you can follow the means of this video reading the subtitles. And we are going to talk about this at the finish, when it's finished.
No, te para el vídeo además.
Okay, I'm so sorry. I believe we have a big problem with the sounds. Anyway, with this video, we want to show more or less how we are training the procedures for passengers and helicopter crew members in all phases of flight, previous safety instructions, emergency during the flight, and emergency procedures to evacuate an helicopter on the sea surface to the water, to the life raft, how to be rescued by a helicopter operation, and also the facilities to train the emergency exit when the helicopter cabin is underwater. By the other way, actually, we are very satisfied with the current work, but in any case, and in the interest of continuous improvement, we have identified some points. For example, the simulators do not represent any of the helicopters in the SASEMAR fleet, mainly the AW139, and all simulations require the installation of equipment, and it's not possible to represent elements such as, example, rain, lack of visibility, seeing the flight through the windows, or the impact with the water. Our general point of view about the training is that different types of training or knowledge areas has different needs and educational methodologies balance. from the theory, role play, and practice. In this case, when we're talking about the safety procedures for air crew or passengers, in a real emergency event, they need to put develop the correct actions in only a few seconds, more or less, and they can't think about what is the correct procedure, what we must do now, how we are going to operate this emergency exit. This a high safety training only be they only must have an adequate safety training program if they practice in the real conditions from real equipment in a real environment. Key points for our aeronautical safety training program by order of importance from basic to high level of quality is learn the correct techniques and procedure, practice in this order, real elements, personal protective equipment like jacket, emergency breathing system, extinguishers, life rafts, etc. in a real environment, on the ground, on surface or underwater. Simulate consistent emergencies with your reality, emergency landing, emergency ditching, smoking caving, and real experience, view, feel, touch, smell. If we add all the previous elements, the result is an immersive learning experience. And a few years ago, in collaboration with CEEI Asturias and a startup from Gijón, we developed our first prototype to incorporate innovative technologies applied to aircrew training. This was developed to validate a hybrid solution, virtual reality, physical environment, and designed to run only one emergency situation, to only one crew member operating a single emergency exit. We have a short video to show how it works. Excuse me, it's only a second. I'm going to try.
To share.
Okay. I'm going to try run this video. I hope it could you can hear the sound. Oh.
You hear the sound?
No,
No.
we are not hearing anything.
Podemos dejar de compartir presentación y volver a compartir.
Bueno, vamos a dejarlo porque este es muy breve.
Maybe the problem is related with the source of your sound.
Okay. We have a few lessons learned after speech one, after the experience with this simulator. The hybrid solution virtual reality physics environment perform a high quality training tool, but it has limits. For example, require high precision with the virtual model and helicopter mockup to allow you to touch the physical elements at the same point you are viewing in the virtual reality. Full body tracking requires to allow efficient emergency evacuation through windows frame or move inside the cabin. Wireless devices are needed. High software development effort do all visual support depends by virtual reality view. Learner only see the virtual world, and this demand a high definition level. A large number of details must be included to let an immersive experience. So, develop a virtual or augmented or mixed reality system that will be overlaid on top of a realistic scale model cabin of a AW139 helicopter, in our case. The objective of the system will be to offer the possibility to train the whole crew of a search and rescue helicopter, 4 or 5 crew members, on emergency and working procedure. We have another short example with this video. This is a video edition result. To achieve the final objective for a full helicopter crew member complete training tool must complain about a few key elements. For example, have the capability to overlay visual effects inside and outside of a physical mockup and facilitate adaptation to different scenarios and aircrafts, but mainly in this case, focused in the AW139. Finally, this is a few resources we offer to startups: full access to training facilities and simulators, AW139 database, picture draws and sounds gallery, arranged visits to AW139 base to collect specific data or validate visual technology solutions, and open mind to accept different options to achieve the objectives. That's all. Thank you very much for your attention. And I don't know if you have any question.
We have, thank you very much, Jesus, for your presentations. Up to now, we haven't had any questions. So I think we can, we have no questions about this challenge. I think we can put an end of this info day, this session. Of course, that it be all by our side. Okay. Yes, we have a questions. I think Mike is for you. This question is for you. I don't know if you are okay.
Yeah.
Is the for an IoT environmental sensor array, how much does it cost? The water sensor provided?
I haven't thought about that for quite a while. I think it was about €200. The water depth sensor, the water velocity sensor, is not available. So we're beta testing it for the company that's manufacturing it.
Mm-hmm. Okay, and could you repeat the size of the transmission messages?
Yes, it was 12 bytes. It's a standard. This is the Sigfox network, and the payload is only 12 bytes. So there's very limited payload availability. Does that answer the question?
Okay, thank you very much, Carlos, for your questions. And also have another one I think is related for your challenge as well. Is valid to use 4G modem and increase the payload files?
Of course, yeah. 4G would be, I think, a valid option.
Okay.
In a way, I would prefer the IoT solution, because that is the that really is the core of this of the challenge. But we're on the borderline with our requirements. That's why we may have to use a communications channel with more bandwidth. Yeah.
Okay, thank you, Francisco, as well for your question. I don't know if we have a new one. We are going to wait just a few seconds. Okay. Okay, I think, yes, we have no questions. So that'd be all by our side. Again, I want to thank you all for your attendance, and also want to encourage participants in this session, especially startups, to participate in this call, to present as many solutions as possible to these promising challenges. Of course, if you have any doubt about how to submit your proposal, something regarding to this, you can contact me. I'll be glad to respond your queries. As I said, that'll be all. Okay, I want to wish you a very nice week, and of course, we are looking forward to hearing from you. Okay, hi, bye.